When you're out there looking at your field, it's easy to focus on the crops and forget that soil matters more than we even realize. Made up of air, water, minerals, and organic material, it's one of the most important natural resources on Earth. Dr. Andrea Basche is an assistant professor in UNL's Department of Agronomy and Horticulture and has been studying soil and the climate's impact on it for years. She joined me on the show to give some background on her work, and she even brought a really cool demonstration too.
So I have a background both in agronomy and climate science, and the research I've done has really focused on understanding crop and soil management strategies to help reduce climate risks. And cover crops has been one thing that I've studied a lot as a climate risk reduction tool. As I started to study more about climate change impacts on agriculture and food production, I got very interested in the soil and seeing that as an adaptation solution. And we hear a lot about people who are thinking about, increased food demand over the next upcoming decades with, increased population. But I really think a lot about the soil and what's our soil resource going to look like by 2050. And that's actually what I'm really excited to show on the show today, that on a positive note, the way we manage our soil can make a big difference on our outcomes.
So yeah, kind of remind our viewers why soil health is so important.
Right, so if you think about soil health like human health, if we don't have our own health, then what do we have, right? So
Sure.
Typically when we think about soil health, that term tends to take into account the physical, biological, and chemical properties of the soil. And the biological properties, really the living organisms in the soil, so the microbes, the earthworms, how alive is the soil, that's the biology. The chemistry being, how well is your soil cycling nutrients like nitrogen or phosphorus. The physical aspects of the soil being things like how well does the soil structure allow plant roots to grow, how much water can be stored. So if you can say yes to all of those questions, then that really is an indicator that you have healthy soil. And what that means for producers is that you're going to have a more productive soil in time that's better for your bottom line, and it also protects your soil resource into the future.
So we've talked about why soil health is so important, and we actually have a demonstration here. What are we looking at?
So what I hope the demonstration will illustrate is just a few different ways that we manage soil and what those outcomes are. And in particular, this is going to demonstrate the infiltration rate of the soil, which means the rate at which water enters the soil, which is so important when we think about getting more of these heavy rain event days. And it's something I've studied. It's something I've also heard a lot of farmers brag about or talk about, in particular some of the cover crop farmers that I know. They love to tell these stories about that day that there was a 5-inch rain event and their soil just soaked up all the rain, but their neighbors had, water standing on their field for days after. So it's a really important aspect of how our soil functions. And so what we have here is soil from the Rogers Memorial Farm, which is a University of Nebraska research station. It's located about 10 miles east of Lincoln. And this soil is from a tillage experiment that's been going on since 1981. It's been managed by Paul Yassa in Extension. And so what we have here is a pretty simple setup. So we've got some beakers that we drilled some holes in the bottom of. We've got some containers to collect water, and we've got some vessels to simulate rainfall over our soil surface. And actually this amount of water is meant to represent about a ½ inch of rain over this surface area. So the three soils that we have here, again, are all from Rogers Memorial Farm. The first one here is soil that has been from that tillage experiment that's been conventionally tilled or tilled with a moldboard plow in the fall and disked twice in the spring since 1981. So managed that way for 38 years.
Nice.
This soil in the middle is a no-till soil, so has not been disturbed at all in those 38 years. These are corn, soybean, crop rotations, dry land experiment. And then the third soil is actually from a grassed area, unfarmed, on the research station, where we just dug up some soil to try to demonstrate what's the difference when you have permanent roots in the soil as well.
So just some natural grass.
Yeah,
basically,
some natural grass.
Okay.
Yeah, and so it's all the same soil type. It's a silty clay loam soil. All right, so you ready to help me, Troy?
All right,
ready
yeah.
to help make
All
it
right,
rain?
let's do it.
Okay, so what we're going to be looking for is how quickly the water is moving through the soil. So, and really, the quicker that the water gets into the containers, the better that would be for water moving through the soil profile for where we'd want plant roots to access it versus running off and taking soil and nutrients with it.
Okay,
Okay?
so count of 3.
1,
Two,
2, 3.
three.
So you can see in the grassed and no-till soil that water's moving quite quickly through the profile. So you can see a lot of water coming out of the bottom here.
Oh yeah.
But you can also see in the conventionally tilled soil that there's less water coming out, it's moving more slowly.
Yeah,
and
and
that
it's pooling up
right,
too.
and you have the water collecting at
Yeah, it's
the top of the
really
beaker.
pooling up top.
Right, so in my own research, what I found is that cover crops, so again, continuous roots in the soil, can significantly increase infiltration rates, and they can also significantly increase the water that's stored in the soil. And actually, what Paul Yassa's long-term tillage experiment has found is that the no-till plots actually yield the highest consistently. This is right now a corn-soybean crop rotation.
And what are some things that producers can do in addition to cover crops to get healthy soil?
Right, so I would like to remind producers more about the principles of good soil management and soil health rather than just specific practices, right? So some of those principles that can be transferred to practices that might work in one area versus another are trying to minimize disturbance as much as possible, trying to use a diversity of crops and possibly integrating livestock, and also keeping living roots in the soil, so things like cover crops, perennial crops, et cetera. So thinking about those principles of good soil management.
So you've gone on record saying that a lot of attention is given to air quality, water quality, not so much or not as much with soil. So what is it that you'd like the public and farmers to be aware of?
Sure. I just think that point exactly, that we never hear about the imperative of soil, right? Soil is just the thin living skin of the earth. It's, not a readily renewable resource, and the need to protect it is really vital. And so just the fact that we don't hear about it enough, in my opinion, I think. So I would say for producers, don't be afraid to remind people that you are stewards of the soil, and for the general public, being more cognizant of the fact that we all depend on soil, to eat 3 times a day.
Definitely. And we always hear stories about how climate change is impacting natural resources. How does that play out as far as soil goes?
Right. So one of the major climate impacts we are already experiencing and can continue to experience in this area is increased rainfall variability, right? So national estimates have found that for regions like the Northern Great Plains, Midwest, Northeast, that heavy rain events have increased over 30% relative to the earlier part of the 20th century. And so with those heavy rain events, you have a chance for increased soil erosion, you have the chance for increased soil degradation, which can lead to lower productivity. So those are 2 major impacts. And when you think about the geologic time it takes to form soil, and we can appreciate that things like rainfall contribute actually to soil formation, they can also contribute to the degradation of soil. But estimates have found that for soil to form, and again, that's really just the breakdown of rock or movement of materials that become soil, that can happen at a rate of about half a ton per acre per year. But when we think about some of the rain events we've had this year, there was actually a few days of rain in eastern Nebraska in early September where we got 6 inches of rain in a few days, and estimates of soil erosion loss for some parts of eastern Nebraska were 3 tons per acre. So if you think about half a ton per acre per year formation, 3 tons of loss in just a few days, it's going to take years to form what we lost in just a few days. So we can lose soil that takes a long time to form in just a short amount of time. So some kind of sobering facts around the need for soil conservation with rainfall variability. But the good news is that we can see that the way we manage soil really does make a difference on outcomes from heavy rain events. And actually Nebraska leads the Corn Belt in the number of acres of no-till. It's estimated to be 50% of our cropped acres. Okay. A little bit less for cover crops. It's just about 2% of cropped acres. Those are numbers from the most recent ag census. We'll have some new data from that out in the spring, but hopefully an increase in some of those things. But we can impact the future and what the growing rainfall variability means for our soil resource.